Hello guys, so today we are looking at this question. It says we should write a function that models the data. Now we're given the data in the form of a table with just x and y values. So what this means is that we're required to write an equation of the function that we can model out from this table. Now that equation can be linear, it can be quadratic, it can be exponential, it can also be a square root function. But most times you check from simple and you begin to check the more complex ones. So first of all, you're going to check for a linear function, if it's possible to get a linear function from this table. If we're going to get an exponential function from this table. So if the function is linear, you know the equation for linear functions is y is equal to mx plus c, where m is the slope. And how you know a linear function is that the slope is constant, so the change in the y, in the side this y, where we have this y, the change is going to be constant. That's how you know. So like where you have 2.5 and 5, where you have this 2.5 and you have 5. 5 minus 2.5 is 2.5. If it's going to be linear, you should expect that what you should have here will be 5 plus 2.5, so that what you have here should be 7.5. But you see that what we have here just highlighted is 10. So automatically you know that it's not linear. It's not linear. If you look at it, you see it's not linear. So you move away from linear and you check if it's exponential. Now if it's exponential, what is going to happen is that there's going to be a constant factor that the y will be multiplied by. So if you go to the y again, let me highlight that. The first factor here under minus 1 is 2.5. That's the first stuff we have there. Now if you check, you find out that 2.5 times 2 will give you this 5 here. And if you multiply 5 by 2, it's going to give you 10. See that? And if you multiply 10 by 2, it's going to give you 20. And if you go ahead and multiply 20 by 2, it gives you 40. So automatically we are now somewhat certain that this is going to be an exponential function. So we work with the skeletal structure of exponential functions. When I mean skeletal structure, I mean the standard equation that represents an exponential equation. So if you look by your left, you see that I've already written out the solution so that I'll make this video fast. This function will have here in light green that's been highlighted. Y is equal to a b raised to the power of x is the standard equation for an exponential function. If you go down, you see I've written a, said a is what? Equal to the initial value found when x equal to 0. So when we say x equal to 0, and of course we have y, we are going to find our a. Now I said b is what? Growth rate, which indicates what? Which indicates whether you have growth or decay. Now what this means is, if you are given the growth rate when you're solving an exponential function, if the growth rate is more than 1, that indicates growth. If the growth rate is less than 1, it indicates decay. So the growth rate is a very important indicator to know if an exponential function is telling you that there is growth or is telling you that there is decay. So in that case, if you need to solve something like that, that's why I wrote this formula here. If you need to know whether it's growth or decay, the formula for the growth rate b is what? B is equal to 1 minus r, where r is the rates for that particular question. Now, for this particular question, if you go back to the table, when you have y as 5, which I've highlighted, if you go up, you see that x is 0. So remember I told you that you will find a when x is equal to 0. So that is why I've purposely gone to where x is 0 and traced the value of y. So we are working with 0 for x and 5 for y. So I'll come back to this standard equation for the exponential function. I'll come back here, and the next thing I'm going to do is, see what I said, when y equal to 5, x equal to 0. This is not magic, it's from the table, please. I've shown you how I did it. So thus, if we put in those values, where you have y, now you have 5, and where you have x, you have 0. Now, coming down, b raised to the power of 0 at this point. B raised to the power of 0 is what? 1. because anything raised to the power of 0 gives you 1. So b raised to the power of 0 is 1. This means that when we have b raised to the power of 0, we can replace with 1, which is what we have done. We have b raised to the power of 0 replaced with 1. So now a times 1 is a. This means that a is equal to 5. That's what it means. That is why I highlighted this. A is equal to 5. So we have found a in the standard equation of an exponential function. We have found a. Now we proceed. Also, when y is equal to 20, x equal to 2. Let's go to the table. You see it. This is 20 for y. If you move to x, you see that it's 2. So it follows. So that's where I got that from. Next thing we are going to do is to substitute y for 20 and 2 for x. So remember, a equal to 5. We found out already. So don't forget that. So what we are going to do now is where we have y, we'll put 20. Where we have a, we'll put 5. And b raised to the power of what? X. But in this case, where we have x, we now put 2 because x is 2. So automatically, if we solve this, you now have 20 divided by 5 is equal to b square, or b square is equal to 20 divided by 5 here. Yeah. B square is equal to 20 divided by 5 at this point. Now 20 divided by 5 is 4. 20 divided by 5 is 4. So b square is equal to 4. Now if you take the square root of both sides, of course you should know you're going to find b. So we take the square root of 4. I will find that b is what? 2. That b is 2. So now that we have found out that b is 2, we'll go back to that standard exponential equation. Y is equal to ab raised to the power of x written in green, and we will substitute the values we have gotten. We'll put a for 5. This is why we have 5 here, and we'll put b 2. So this is why we have 2 where b is supposed to be. We'll leave y and x. So this function here now models what we have in the table. So it's the function that represents what we have in the table. Now if you doubt it, take your time, pick any value from the table. Let me say 3. So when x is 3, put 3 where you have x and solve. You're definitely going to get 40. If you want to, you can put 1. If you look at it itself, you can put 1 here, just looking at it to show you. If you put 1 in the place of x, you have 2 raised to the power of 1. And 2 raised to the power of 1 is 2. 2 times 5, 10. Automatically you have 1 and 10. So it's right. So it's right. So you can put any function, any value of x you want. There's minus 1, there's 2, there's 3, and check it out, and you get the corresponding value in the table. So this is how you model giving data from the table if you are not actually told what it is. So thank you for watching. I hope to see you soon, guys. Take care.